Welcome to Off Hours, a conversation between John Edwards and Chris Manning.
So last episode, I mentioned the Longines annual calendar and how not many people had been talking about it. And prior to us publishing it, I actually hadn't seen any articles at all published. And one of the things that most impressed me about this piece was how aggressively priced it was. And it is so aggressively priced, it turns out, that I interpreted what my contact at Longines had told me was the price in Swiss francs as the wholesale price, when in fact it is the retail price. So when I said that the Longines annual calendar was a steal at around, I was guesstimating about it would retail for about 4,000 Swiss francs. It turns out that you can get it as low as 2,100 Swiss francs on a leather strap. So that turns out to be about 2,500 US, about 27.50 Canadian. I don't know the official Canadian price. It's not actually going to be released until the autumn, and markets flux in that sort of span of time. So we'll see what it actually comes out to be in Canadian dollars once it drops. But that is an absolutely unreal value as far as an annual calendar is concerned. Never seen anything come even close to that. And on top of that, you're getting a tried and true time-tested base caliber that's been upgraded with a free-sprung balance wheel in addition to the upgrade to the calendar system. All in all, just absolutely phenomenal value for the money in that category. Nothing else comes even close. As we mentioned last episode, the next closest is about 6,000 Swiss francs. So you're looking at 3x the price, and then you're also going to be sacrificing the free-sprung balance wheel to get your hands on a piece that's cost you 3 times as much. Yeah, that to me is the most bang for your buck at Baselworld 2018. It's the Longines annual calendar.
That's unbelievable. At the price that you had said earlier in the last episode, that was still an amazing price. But knowing that it's even cheaper than that is crazy. I don't know how these guys are doing it, but I guess that's the benefits of mass production, right? You can once you get these things designed and you get the manufacturing process worked out, they're not working with precious metals in this case, so they can certainly get the costs down just through improved manufacturing.
Mm-hmm.
And in a bit of follow-up from me, it seems that every episode I talk about somebody who's Japanese, I manage to either mangle their name or completely misattribute who it is that I'm talking about.
You just have to go back and visit a little more often.
I do, and I'm seeing all these beautiful photos from when I was there this time last year. And for those of you who aren't living in the Great White North, it is currently ice, rain, and snow outside. So being in Japan right now would be a nice change from where we are right now. But last episode, I had spoken about a watch that's the length of each hour adjusted with the length of day. And the maker of that watch was Masahiro Kikuno. He is the one who created that, and the video that we linked to was in fact the correct video, but it was Masahiro Kikuno who made that watch.
How are things coming along with your watch project?
Things are going pretty well, actually. I think I'm around 80% of the way there with a watch case design. So I'm at the point where I have the rough model for the watch, and I've started refining it. And there are a few details that I won't be able to really refine until I've had a chance to make it and build it in metal, so that I can get a sense of how much material I actually have to work with, and if it's too little, if I haven't left myself quite enough room, things like that. So I'm getting pretty close, and since I've gotten close to a model that I like, and in fact I have a model that is at least it looks complete. If you looked at it, somebody would look at it and say, "Hey, that's a finished model," but there's still some details missing from it. I have started to prototype it a little bit, and the first step in this case was I've decided to 3D print a version of it, since I could print one quickly and check it out on my wrist and compare it to some of my other watches and see how it matches up.
So what do you think now you've had your first opportunity to actually put it on your wrist?
Well, so far I'm pleased. It's I think it's going to work out reasonably well. It's not too thick and it's not too ridiculously large. It's going to be a 42 millimeter diameter case, so I had a pretty good idea of what the watch case size was going to be like in terms of diameter. The things that I was most concerned about were going to be the depth of the watch, the thickness of the watch, as well as the size of the lugs. I'm a little concerned that the size of the lugs was too small, but I think it's going to end up being okay. Sometimes that sort of thing is a little bit deceptive in a model, and it looks as though it is too thin and can't actually handle what it's going to be doing. So in this case, the lugs obviously are holding your strap on, and you want to, you don't want those to be too small. You want them to be beefy enough to actually withstand the abuse they're going to go through just keeping the watch on your wrist. And it's sometimes it's a little bit difficult to judge those kinds of things in a 3D model. So that's why at some point you do need to take that 3D model and start prototyping in a physical material so that you can get a sense of what it actually looks like in the real world.
So what is the material that you've done your initial 3D prints in?
In my case, I have an SLA printer, and we can go into some details about different types of printer technologies in a bit. But I'm using an SLA printer, which uses various photosensitive resins to print in. It's the particular resin I'm using is from Maker Juice Labs. It's their SF Plus resin. It's a fairly inexpensive resin that's designed for sort of quick prints. It'll create a reasonably durable model quickly. This one happens to be an orange. It's a bit of an odd color, but it works for what I'm doing. And the goal here is to be able to get a quick print that I can then throw on my wrist. So in my case, I guess it took around 5.5 hours to print the model. And it's not a perfect model by any means, but it is dimensionally very close to what the final piece will be. It was a nice quick way to be able to actually put something on my wrist without needing to go through the time and energy to machine something out of brass, let's say, as a prototype and do that. Same thing. It's faster than trying to mill something or turn something out of any material. I can just let the printer do its thing and go because I've already got a 3D model working from the design process. So it was a pretty easy transition to printing something off.
No, I haven't printed a watch case with an SLA printer myself, but I know a couple of other people who have, and I've heard from them they find they get better results printing it on some sort of an incline rather than just straight up vertical or horizontal. Did you mess around with that in any way?
In my case, I had to print it on a bit of a vertical or a bit of an angle. I find that with this printer, and I suspect that this is mostly to do with my inexperience right now with the printer and needing to tweak the settings a little bit, but I find that when I print things vertically, that first sort of layer of the model itself that's connected to the supports tends to get misformed. And I think what's happening is the resin isn't curing fully. And so as it has all of the weight of the rest of the model on it, tends to misform a little bit as I'm going. I have actually found in my situations, even though you get a more accurate print in terms of the detail by doing it on a bit of an angle, I find that I get more accuracy in dimensions if I go, let's say, either perfectly flat or perfectly vertical. And so it's a bit of a trade-off, I guess, for me. I'm getting slightly better quality prints just because I'm getting something that's more dimensionally accurate if I print it vertically or horizontally versus putting it on an angle a bit.
Now, going back to the lugs, I noticed your print bears some resemblance to the Langenzona prototypes that you and I chatted back and forth a bit about there, where the lugs are created together in a set of 4 and then set inside of the case. Did you do you this print as two separate prints, or is this a single print with just a similar sort of form for what compared to what Langenzana did?
I like the idea of what Langensona did. I thought it made a lot of sense in terms of trying to make sure that all of your lugs are lined up properly and square, and certainly makes the manufacturing process a little bit easier. So I'm going to give that a try and make sure that it works well for me. I can't imagine that it'll be a problem if it's something that's working well for them. And in this case, when I modeled it, I was just modeling the lugs up together in one piece and then adding it to the model. So when it came to printing it, it just made sense to leave all the supports in place. When I was printing it, I didn't want to have to go and remove them just for printing up a 3D model that was only for me. And then when it came to printing the model itself, I decided to just print it as a single monolithic piece. When I actually get around to manufacturing this, I suspect that I will be printing some of these parts, if not all of them, for casting. And in that case, they will all be printed as separate parts and cast separately, and then they'll be machined properly afterwards to fit each other, and then assembled probably by soldering them together and making sure that all the dimensions are proper for what they need to be. So it'll be a combination of some casting and some machining that makes these cases. And depending on what works best for me, I suspect that some of these parts will be printed. Some of them may just be turned out of wax. Things like the center band or the bezels that are on it, it will probably be faster and more accurate for me just to turn wax versions of them on my lathe and cast from those. But for something like the lugs, it will probably be faster for me just to print them and then cast from a printing.
Mm-hmm. Yeah, 5 hours to print a cylinder isn't very, very effective.
Yeah, it's not a very effective use of my time or my printer's time if I'm sitting there printing the whole thing. Whereas I can, most of those parts on a lathe with wax, I can have those turned in a minute, 2 minutes. They'll be very, very fast for me to turn and won't cause me any problems. The thing that will probably be printed will be the lugs, and those I can print much faster than this particular print job. One of the limitations that I have with my particular printer, I have a small SLA printer designed for jewelry from MakeX. They're a small firm out of China who have done a few Kickstarter projects, and this was one that I backed on Kickstarter a few years ago. It's designed towards the jewelry industry, and it has a reasonable sized build envelope for a high resolution jewelry printer, but it's still not massive. And in fact, in this case, it's small enough that I cannot lie a 42 millimeter diameter cylinder flat on that print bed. It's just too small to be able to do that. I can't print a full case or even one of these full rings lying horizontally on the bed. So in my case, that would limit me being able to print these easily in that printer if I was trying to do the whole case and everything. But the lugs themselves will easily fit within the build envelope of this printer, and so I suspect I will probably print the lugs and then cast from there.
So the lugs should be able to print a lot faster than being more horizontally inclined than being more vertically inclined.
Yeah, I suspect that I can probably print a set of lugs and maybe even 2 or 3 sets of lugs at the same time, and the job will probably take less than an hour to print them. So that will be significantly faster than any other method. The way I would have done this before I had this printer is I would have milled them out of wax. And for something like this, I could probably reduce the resolution a little bit on it, but it would still likely be a 7 or 8 hour job to mill these lugs out of a block of wax. And this way I can do let's say 3 sets of lugs in a fraction of the time. So it doesn't make a lot of sense for me to mill them out of wax, especially when, regardless of the method that I use, I will need to sit there and refine them a little bit after they've been cast to make sure that they fit properly and to make sure that the shape is proper. So regardless of which method I use, I am still doing hand finishing and hand fitting on them afterwards. So the slight inaccuracies that I get from the 3D printing versus the milling, it's just not worth the significantly longer processing time to mill them. In other cases where accuracy is tantamount, using the mill is certainly the way to go. But for something like this, it's just not worth it.
So is the end goal to be casting these in Palladium 500?
We'll have to see what the final materials are going to be. I think I'm going to choose a few materials, and I don't think I've settled on exactly what they're going to be. Now that I have a model that I'm happy with, and I have dimensions that I think are going to work for me, the next step is I'm going to actually machine them out of solid brass. So I have some solid brass rod in the shop that is large enough diameter for this, and I will turn out all of the various components of it out of brass. And in the case of the lugs, I will probably just cut them out by hand and do them manually and fit them up manually. So I'll make a brass version of this watch next. The final versions, obviously, I'm not going to be making in brass. And I should say the reason I'm going to work with a brass model next is that it'll give me the ability to work on fitting the movement and the dials into the watch. The resin version that I have printed now, while it's very close to being the correct size, it's not 100% perfect. It's off by a few tenths of a millimeter here and there, which doesn't sound like a lot, but of course, when you're trying to fit movements into a case, when you're trying to fit dials and things like that in there, being off by tenths of a millimeter here and there makes a big difference. So the next version will be in brass, mostly so that I can make sure that I have all the correct clearances. I've got all of the I've got enough room for everything that I'm trying to stick inside of the case. From there, I'll probably make a silver version of it, just because the silver is inexpensive for me to work in. I've got a pile of it around already that I can prototype in. So I'll cast some parts out of silver. And the reason for that will be so that I can work on the final manufacturing process. And in my case, that process is going to involve casting, cleanup, soldering, and then doing the final work on it after that. And so the doing that process in silver will allow me to make sure that do I have enough space for for all of the little machining details for making sure that things fit together properly. I've got little bosses in place on parts to make it so that they fit together properly in the soldering process, and I want to make sure that all works properly. And if I can work in something like silver, which is relatively inexpensive to work in, and it's easy for me to cast, then that's the next step after that.
Now, what drew you to invest in the MakeX printer as opposed to a competing SLA printer?
I'd been looking for an SLA printer for a while. Of course, cheap 3D printers are everywhere, but most of the cheap 3D printers out there are using some sort of an extrusion. Most of them are using what's called fused deposition modeling, and they're usually using an ABS or a PLA to print with. So it's usually coming off of a spool, and it's a filament that they're heating and then sort of injecting down. Think about it like a highly accurate glue gun that you're using to make the model. And while that works great for a lot of the projects that people want to build, and it certainly works really well if you're building larger models, it doesn't have anywhere near the accuracy that's required for doing jewelry work. So the SLA printers are using a photosensitive resin to print at much higher accuracy levels than the extrusion-based printers are. So I'd been looking for one for a while, and it was, I guess, about 2 years ago, they were starting to come down into a reasonable price range. These guys had done, there were a number of Kickstarters out there for SLA printers. I wasn't horribly excited by a lot of them. A number of the companies that were doing it had never really made a printer before. So, of course, that's one of the problems with Kickstarter. You have to be a little cautious about who it is that's making this thing. In the case of the MakeX people, they had already made a few printers and sold them, and they were successful, and they were getting good results out of them. And their earlier SLA printers were geared towards larger scales, so lower resolution, larger scale pieces. And this one was geared towards jewelers specifically. They had two versions, one with slightly larger build volume, which is the one that I ended up going with. And the price was right. I got in on an early bird option on the Kickstarter, so I paid significantly less than what I think they're going for now. So between the price and the features that it had, it was a pretty good deal. If I had to pay full retail, I probably would have gone with a different option. And I suspect long term, I will probably look at other printer options, because this is not the highest quality printer out there. It's certainly good enough for the experiments that I'm doing and for the initial work that I'm doing with 3D printing, but it's certainly not the printer that I will go with in the long term.
Did you look at the Formlabs printers at all when you're looking into buying a printer?
Yeah, the Formlabs printers were on my list of they were sort of on the short list when I was buying them, and I know a few people who got into buying Formlabs printers early on when they were slightly less expensive than they are now. They certainly make great printers, and they're one of the better printers in the mid-range of SLA printer in terms of their usability. They've done a great job of making a nice usable product that's very reliable. They've got a great company that's backing them, and they're certainly worth looking at if you're looking for something like that. I do know a few jewelers who are using them, and they've been reasonably happy with them. I do know that there are some, if you're doing jewelry level work, there are some better printers out there in similar price range, maybe a little bit more expensive, that are more accurate. But then they also come with being a little bit more fiddly when it comes to working with them. One of the things that Formlabs has done a great job of is being able to network multiple Formlabs printers together to create a manufacturing environment. So the printer that I would be most likely to look at is the Form 2. And with their Form Cell technology, you can take 2, 3, 10, 100 printers, however many you have, and you can essentially gang them up together to easily print as you need a printer. So it knows which printers are in use, which ones are the next ones coming up to be available, which ones have which material in them, that kind of thing. And so this cell setup will monitor the print job. When the print job is done, it will remove the previous print job from the printer, and then the system will automatically start the next print job on that printer as necessary. So it takes this rapid prototyping technology and turns it into an actual production technology, which is interesting. And you can do sort of lights out manufacturing with it. I don't know how well it works. I haven't really, I've seen a few videos, sort of marketing videos from them about the process. I haven't seen any good videos from people who are running it and how well it worked for them. But they are certainly working towards turning this into a significant technology that you don't have to, you don't have to just use for rapid prototyping. You can use it for full-on manufacturing if you want to.
I know Nervous System out of the States there, they do a lot of custom jewelry that's based on a lot of biomimicry. They recently took receipt of their new Formlabs equipment, and I know they were boasting that it certainly makes the process a lot cleaner for them. So it'll be very interesting to see how this all plays out with Formlabs.
Mm-hmm. And it looks like they have a new product coming out that's a laser sintering printer. Now theirs is designed for sintering it looks like a nylon powder together, so it's not a metal powder, but that will probably be quite good as well once that comes out and it's out on the market, because I suspect it'll, if nylon is a material that you can use for your final product, or you can make a mold off of it or something like that, that's probably going to be pretty accurate and fast to build.
Mm-hmm. And Shapeways has been rolling out nylon-based 3D printers recently, in more of a beta phase through HP. If I remember right, I think I may have a discount code for print in that particular material. So if I'm able to dig that up, I'll be sure to stick that in the show notes for people if they want to take advantage of that. Yeah, I'm actually in a bit of a similar situation with my 3D printer. I have a filament-based printer that I don't use for any parts manufacturing, but I'd use it to make a number of jigs and tools and aids around the shop. And I find it really handy for that. Everything from making replacement parts for, say, watch winders, to making jigs for holding movements, to jigs for holding cases, special dies for pressing on bezels or pressing fancy shaped crystals back in place, all this sort of stuff. I find it really handy to have a filament based printer kicking around of the type that you referenced earlier. Yeah, I've been primarily very pleased with mine. I got it for a really good price about 2 or 3 years ago. There was a sale on the PrinterBot Play, which, like your machine, also has quite a small build volume, but it's suitable for the sorts of jigs that I make with it. Over the years, entropy has kicked in, and I'm finding it more and more of a frustration to use. It's also been through a number of iterations from the company, and support channels are not the greatest. So I'm leaning towards something that's better supported going forward, because they've actually discontinued the Play, and it's gone through so many different iterations that actually trying to troubleshoot things now through their forums, you end up in a web of potential solutions that don't always work. So clogs have been becoming more frequent, and I'm actually looking at replacing the extruder portion of the machine now. But with the number of upgrades that I've put into it over the years, like heated bed and increasing the build volume and that sort of thing, between that and the time I spent troubleshooting, I probably would have been better off going with something like a MakerBot Mini or that sort of thing. So I think for my next round, I may shift towards a more commercial type printer, like a higher end consumer grade.
I was a little surprised. I was speaking with a friend of mine recently who was he's been using one of the Monoprice printers, and I didn't even realize Monoprice had been building their own little printers, and he's been very happy with it for the price. And in fact, they've just released a new small SLA printer. Although I say small, it has a slightly larger build volume than the one that I've got now, and I want to say that it's $500. Their extrusion printers, their small extrusion printers, are even less than that, maybe $350, and they look like they're pretty good little printers. Some of them have heated build platforms and everything like that. So this is one of those industries that is changing so rapidly. It's not like buying a lathe where, last year I bought a Cromwell lathe that was built in 1947, and it is still an immaculate lathe. It works beautifully. It is incredibly accurate, and I can do 99% of the work that I want to do on a manual lathe on this thing. In the case of 3D printers, anything that you buy today, expect that it is going to be obsolete in 18 months or less. It is such a rapidly changing industry, and the cost is changing dramatically. So it's certainly something that if you don't need one today, or you want one just for sort of experimenting with, it's certainly worthwhile getting one of the low-end ones, one of the really inexpensive ones. Learn the technology a little bit, learn how to build, and then move to a bigger and better one later on once you have a better idea of what it is that you're looking for. But just because by the time you actually get around to needing the better printer, you may find that it is dramatically less expensive or significantly better than it was.
Mm-hmm. You have a friend in Switzerland who also bought the printer bought Play around the same time that I did, and they've also recently switched over to a remarkably inexpensive 3D printer that I believe they got through, let's say like Banggood or something like that. So kind of similar to the Monoprice,
Yep.
sort of budget electronics online marketplace. Yeah, everybody's getting into the game. Even Dremel has their own 3D printer now, and they're getting into laser cutters now as well. So there's certainly no shortage of choice when it comes to investing in a 3D printer, which also comes with a world of potential problems. It's hard to judge the good from the mediocre.
I think with many of these products, you need to be realistic about the quality that you're getting out of the printer. If you're buying a $500 printer, it's a $500 printer. It is not going to be the same as a $10,000 printer. In my case, I knew that the printer that I was getting for $2,000 was going to do good work, and it was certainly going to do something that I could work with. So, for instance, I've been printing off parts for some of my pens on it and casting from that. I've been printing some cufflinks recently, and for that, it's absolutely perfect. It works really well. It's fast. It's accurate enough for what I'm doing, and I know that the next step up for me from this $2,000 printer is probably getting into a $10,000 printer. At this point, I just can't justify doing that until I know that it's actually going to be able to be a tool that will allow me to actually work effectively and work faster. Otherwise, it's just not it's not something I can justify buying for the shop. $10,000, I can get, I can start getting myself into other machines that I know will do great work for me. And so I have to be cautious about how much, if I'm going to be spending that much money on it, is it going to be worth it? But when I get into some of the higher end printers, some of the stuff from, let's say, B9, like their Core 550, or getting into the Envision Tech ones, at that point, I'm getting into printers with larger build volumes, higher accuracy, faster in many cases. So the B9 can probably print at 3 times the speed that my current Make X does. And between the faster speed plus the larger build volume, all of a sudden I can go from printing, let's say, 2 or 3 of a part at a time to, printing a dozen of a part at a time, and it's taking a third less time to print those dozen parts than it was to print the 3. So it's amazing once you get into these higher end products, just how much better they are than the lower end ones. But as long as the lower end one will do what you're looking for and will actually is good enough for what you're doing, then it's certainly a good place to start. In my case, I usually just let the printer run overnight. So if it's a little bit slower, I'm not too worried about it. Or if I need to do, let's say I have enough parts that I need to print it in 2 or 3 jobs, then it's not the end of the world. I'm not working to such a tight timeline right now that I need to worry about that. But at some point or another, that will become a limiting factor for me. And, I will need to print off enough parts at one time that I can't wait for the printer to be going at a slow rate. I will need to either get much faster printers with bigger volumes, or I will need to get multiple printers that can be working together. So one of the advantages of the SLA printers, they are using, in the case of mine, they're using a projector that's been modified. They've taken the UV filter off of it, and they then project an image onto the bottom of the tank, the resin tank. And the advantage of that is that you don't have the same risk of overheating like you do with the nozzle on yours. There are also slightly fewer moving parts because you don't have to move the nozzle in X and Y as well. You're just flashing a slice of the model onto the bottom of the tank and allowing it to print that way. So there are some advantages to SLA, but they are more expensive typically because they do need the projector in there. And some of them also use a laser to do it, although fewer and fewer people seem to be using lasers in their their builds, just because the projectors these days have gotten so good and inexpensive that they can get away with it. So, yeah, there's certainly some advantages to going with the extrusions. There's some advantages to going with the SLA, and but it just really depends a lot on the build volume that you want and the resolution that you want in the parts.
Yeah. And if you really want to get fancy, you get into selective laser sintering and printing right into metal. That's definitely out of my league.
When I was speaking at the Santa Fe Symposium last year, one of my co-speakers was Damiano Zito. I think that's how you pronounce his name. He works for a company called ProGold in Italy, and they are doing selective laser melting. So there's a slight difference between the sintering and the melting operations. The sintering, it's not. We've been talking about 3D printing into various plastics and resins and whatnot, but there's also technology for going into or for printing in metals themselves. And typically these are using powdered metals that are then sintered or melted together by a laser, usually a fiber laser of some kind, into the part that you're working on. And these, it's really interesting watching these printers because they will put down a very thin layer of metallic powder. A laser will go over the entire surface where your part is going to show up, and they fuse the particles of metal together. And you can use this technology for doing everything from gold and platinum to titanium and Inconel. So there's a wide range of materials that you can do with it. You can use stainless steels, everything. So Damiano is doing interesting work with platinums where they are using a laser melting technology to completely combine the particles together, and it allows them to print objects that cannot be manufactured in any other way. They're focused on jewelry work, and the parts that they are producing cannot be cast. They cannot be machined. I suppose you could probably fabricate them if you had the time to do it, but they're very complex parts that are quite interesting. But watching these things work is pretty fascinating. That the big downside of them is that you need a huge amount of metal for the process, because the build tank has to be filled completely with metallic powder. So in the case of these printers, I want to say that each one of these printers needs 3 kilos of platinum powder to fill the build volume. And so when you start doing the math about how much money is required just in metal to be able to fill the tank. Now, of course, that powder, any powder that you don't fuse or melt together can be reused, right? You can clean out the powder that isn't used and recycle it and reuse it. But still, you need 3 kilos of platinum in your printer just to make your first print. So that's quite expensive. Some of the newer technology that's out there that's great. There's some. We'll put some examples from DMG Mori and Mazak, who are companies that have traditionally made high-end machining centers, CNC machining centers. So they're doing 3, 4, 5, 6 plus axis mills that are able to produce very, very complex parts from using subtractive machining. So you're taking a solid block and you're using a mill or a cutting head of some kind to subtract material from it. They've now added selective laser sintering to as a machine head, basically, on the parts or on the mills, and they're able to take a piece that's been machined, build up material. Let's say it might be a fin or a boss of some kind. They're able to use SLM technology to build up that material again, oversized, and then go back afterwards and mill it to the proper shape. So there's some great work that people are doing with that. Now the costs of getting into doing it is just astronomical, but and unfortunately not appropriate for what I'm doing yet. But yeah, there's some amazing technology that's being used for additive manufacturing these days.
And while it's not as fancy as the SLM, one of the nice things about having a little printer kicking around the shop is that you can very quickly iterate and prototype something. And then if you want to have it printed in metal, such as the stainless steel or gold or titanium, like Chris alluded to, aluminum, brass as well, there are third parties such as Shapeways in the States and iMaterialize over in Europe, where you can submit a 3D model that you wish to have 3D printed in metal, and they will actually do that for you. And with a matter of weeks, you can get that in your hands in fully printed metal. And it's good to keep in mind that your tolerances are going to be different between these machines, and these aren't parts that are going to be on par with having something milled to very fine tolerances, but it gives you a good starting point, or allows you to iterate and prototype very quickly and get something in your hands in the metal without having to outlay the hundreds of thousands of dollars for a full-blown machine on top of the hundreds of $1,000s to fill it with 3 kilograms of gold or platinum or what have you.
Yeah, the 3D printers are certainly good for prototyping, and they're certainly usable for that. I'm finding that they're actually they're effective for manufacturing as well if you're producing in small quantities. In my case, this particular watch case that I've printed out is in a fairly durable resin. However, I also have resins that are designed for people who are casting, and these resins have a very high wax content in them. As we discussed on one of the earlier episodes when we're talking about lost wax casting, you need to have some kind of a master model that you're casting from, and that's what creates the void in the flask that you'll eventually pour the metal into. That model needs to be destroyed. It needs to be burned out from your flask, and you don't want to use just any material when you're doing that. In my case, I have a few different resins that I've used. B9 Creations, they have an emerald resin that's quite good. There's also a new one that's out on the market, or a newer one that's out on the market. It's from a company called Bluecast out of Italy. And both of these companies have done great work in creating these resins that have very high wax content in them, so you can print accurately in them. And then you can invest them just like you would a wax. And the burnout process is very similar. There's a slight difference to burning this resin out versus just using a normal jeweler's wax. Normal jeweler's wax will melt out very, very easily compared to this stuff. But it will burn out. And as long as you're careful with it, they are very accurate when you're casting with them. You do have some expansion issues, unfortunately, with them. If you're not careful when you're burning them out, they can expand a little bit too much and change the dimensions of your piece while you're burning them out. But otherwise, I'm getting some great results out of them. They're not quite as accurate as the stuff that I was milling in jeweler's wax, but in most cases it doesn't matter. It's so close that I'm the only one who knows the difference between what the part would have looked like if it was milled versus printed. And they are significantly faster than, I can print off a few pen barrels at a time in less time than it would take me to mill a single one. So the speed advantages are significant, and the decrease in resolution is not significant.
Now, 3D printers have been a core tenet of maker culture over the last decade or two. And you're going to be heading off to a maker fair in the not too distant future. You want to mention that?
Yeah, coming up in May, friend of the show, Rich Lowen, and I are going to be flying over to the UK to visit Maker Central. We're actually going to be setting up a booth there for Rich's design company, Lowen Design. And we'll have one of his fun little CNC projects set up there to work. And we'll be demoing that at the show. I'm looking forward to getting a chance to visit some of the other makers over there. This is my first time visiting sort of the maker culture in Europe. I'm spent a lot of time in the UK itself, but never looking at this side of things. So we're looking forward to that. That's the first weekend in May. So if you happen to be in the Birmingham area that weekend, you might want to come and check out the show. Looks like there's going to be some interesting people there. Certainly, if you follow any makers on YouTube, it seems like half of the YouTube world is going to be there. So there'll be some interesting things to take a look at and see. And we're looking forward to that. So if you happen to be in the area and you stop by the show, come by the booth, the Lowen Design booth, and say hi. It'd be good to chat with you and hear from you.
Thanks for listening to Off Hours. You can find detailed show notes at offhours.show. If you'd like to keep up to date with the show, follow us on Twitter @offhours. John can be found on Twitter @UnderTheLoop, and Chris can be found on Twitter and Instagram @silver_hand.